Look at perfect squares, we will look at them in terms of, okay, what squared gives me that thing? And once again, at the end of the class today and on Thursday, we will look at perfect squares and go, that's got all the markings of a perfect square. I'll bet it's this binomial squared. So let's not forget where perfect squares come from. They come from binomials multiplied by themselves. There are other problems in your text, like, yes ma'am?
Okay, this might sound kind of stupid, but will it always be the fact, like when they say factor the perfect square trinomial, and they give you whatever, will it always be this perfect square of the first and last term squared?
Yes.
It's always,
if it's a perfect square, it'll always be the square of the first term,
and the last term.
square of the last term, sine of the middle term, squared.
Why would you not have 30x squared instead of 2x?
Okay, now I got 15x plus 15x, right? So when I'm adding, I don't change the exponents. So it stays x's. I only use the first property of exponents when I'm multiplying. So 3x times 3x, yeah, that's 9x squared. Somebody needs some WD-40. I thought that was my own back. All right. Yeah, we all need some. There are some other multiplication examples in this text, like x plus 5 cubed. I'm not really interested in that. You could, if you want to know what x plus 5 cubed is, multiply by itself 3 times, okay? You don't need to know a standard description of what happens when you cube a binomial. It occurs so rarely, just multiply by itself as a factor 3 times to find out what happens. All right, let's look at some of the problems in your text. This is on page 35, if you happen to bring your textbook with you, page 35. Actually, it's on page 35, even if you didn't bring your textbook. So, whether you brought your textbook with you or not, it's still on page 35. Now notice what you're asked to do here. Find the area of the shaded region in each figure. Write your result as a polynomial. There's the application. There's why this is in this section. Polynomial in standard form. Hey, you know what they're asking you to actually do here? Remember something from your geometry background. How rude is that? They're asking you to actually remember what you've learned in the past. What are they going to ask you to do next? Got at least 2 things to do here. One is the area of a rectangular shape. How do you find the area of a rectangular shape? Length times the width. Everybody got that? Length times the width. And we got several triangles. How do you find the area of a triangle?
1/2 the height.
Base times the height divided by 2. Okay, or 1/2 base height or base height over 2. Either way. But it's the base times the height divided by 2. By the way, if I say base times the height, and we're looking at a triangle like that, that's obviously the base. What's the height of the thing? From the top point down? Oh, straight down. Meaning what? Give me a word. Give me a word. Could be. It is in this case.
Horizontal?
That's our word. Give me a further description other than straight down. Right down the middle. Right down the middle. Well, it's right down the middle in this case, but in this case, right down the middle is right there. Is that the distance you want? Why is that the height? What kind of distance is that? Yeah. That is the highest point. It's from the vertex to the base, but I need a word. Thank you. It's perpendicular. It's the perpendicular distance, all right? all of these are distances from the height, you could say to the middle of the other side. That won't cut it in this case. But perpendicular distance, you got the height. Okay. What's another word for this guy right here? What is this? It's got a name. You talk about triangles. Altitude. Who said altitude? Oh, you said what? Thought you said altitude, all right? Altitude is right. You were thinking altitude, even though you said Opelousas or something. Okay. 111 here. Let's look at the rectangle, then let's look at one of these triangles. Here's what it looks like.
Move it down,
All right, and we're looking for the shaded area. All right, somebody got it straight. Don't give me X's and multiply, don't give me X's, but tell me what's your strategy for finding the shaded region.
The area of the large rectangle minus the area of the...
How many were thinking that? Okay. How many weren't really thinking that, but saying they're thinking that? All right, so hey, it's the area of the big rectangle minus the area of the smaller rectangle. That leaves the shaded area, right? So here we go. So you got area of big minus area of small equals area of shaded, right? That's basically the strategy. And it looks like a good one. How are we going to find the area of the big one? What times what?
Many times with
2x times 2x plus 6. So it's the length times the height. Here's the area of big minus the area of small, which is going to be x times x plus 4. That equals the area I'm interested in. So a little bit of distributive here. Is that right? That look all right?
No. Where's x squared?
Problem?
X
Somebody's got a problem?
squared.
X squared. Plus 4.
Oh, x squared plus. Okay. So now is it okay?
Yes.
No. Minus 4.
You guys are just all sorts. So minus 4x. So negative x times 4. Yeah, you're right. It's minus 4x. Okay. We got minus x squared minus 4x. There, I just got like terms to get together. Let's see. There's some like terms. 12x minus 4x. Oops, I got a minus x squared. That got 2, right? So I got 3x squared plus 8x. Who is squeaking? There are other seats if you can't sit in the chair without squeaking. All right. Not a problem, right? Big area minus little area equals shaded remain. All right, let's do one more. Which one of these you want to do? B, C, or D? How many want to do a B? See those hands? B, C, D. D looks pretty challenging. Let's do D.